In this video, we're going to look at finding the zeros of a polynomial function and then writing the function as the product of those zeros. Excuse me. The proper form for writing a factor from a zero is x minus the zero, okay? And so what we're going to do first is just look at writing a couple of factors from a zero that's given to us, okay? So let's look at this example right here. Write the factor from the given zero. If our zero is, if our zero is x is equal to 3, we need to write a factor with 3 as the zero, okay? So what we need to do, excuse me, is write x minus that 0. Well, the 0 is 3, so 3 is what we put there. So x minus 3 is the factor from the 0 of 3, okay? This is kind of working backwards. We're used to doing the factor first and then getting the 0 from that factor by setting the factor equal to 0 and solving for x, okay? So that's kind of where this is coming from. You can double check to make sure you've got the right sign by setting that factor equal to 0 and solving it, okay? This works for imaginary numbers as well. If we look at example number 2 right here, our 0 is the imaginary number negative 4i. And in this section of 3.4, we're going to deal with a lot more imaginary zeros than we have seen up to this point. So what you do in a case like this is the same thing we did for the 3. You just do x minus that 0. Well, the 0 is already a negative 4i, so the minus and the negative come together, and that becomes a plus. Because if you're subtracting a negative, that's the same thing as adding a positive, okay? So our factor for that one is x plus 4i. And then this last one's a little bit tricky. We do have another imaginary 0, and it's a 2-term imaginary 0. So what we do is we say x minus that 2-term 0, and what you want to be sure that you do is you distribute this negative to both terms, okay? You're going to change both of those signs, and so that becomes x minus 1 plus 2i, okay? So we get a 3-term factor in that instance. All right, so let's take a look at a problem that we're going to start from the beginning. We're going to be given a polynomial. We're going to need to find the zeros of that polynomial, and then we're going to need to write those zeros as factors, okay? So let's look on the next page at our problem. Find all of the zeros and write the polynomial as the product of its leading coefficient and its factors, okay? This part right here, the leading coefficient part, if you have a number out here in front of your degree term that's something besides the positive 1 that we have for this particular one here, what you'll do when you list your factors at the end is you'll put that in there with them, okay? And I'll show you where that goes when we do this example, even though our coefficient here is just a positive 1. It's easy to tell where it goes, so I'll put that on there as we go. All right, so our first problem here is to find all the zeros, okay? So we're going to start with the rational zeros theorem. And we are going to take the factors of the constant term, which the constant term is just positive 9, so we don't have a lot of factors, plus or minus 1, 3, and 9. Okay, and then we get really lucky because the leading coefficient right here is just a positive 1, and that list is going to be super short, just a plus or minus 1 for that. So our list of possible rational zeros, which is made up by taking each p over each q, will be 1 over 1, 3 over 1, and 9 over 1. So we get plus or minus 1, 3, and 9 again. Okay, we don't have another factor of leading coefficient, so I don't wind up with any fractions, okay? And that list has only got 6 numbers on it, okay? You can, at this point, go ahead and do Descartes' rule of sign if you want to. It turns out not to help us very much in this particular example, so I'm going to skip it for the sake of time. But if you want to try it out, you can. There's sometimes when it's beneficial because it may tell you that there are not any positive real zeros or there are not any negatives, and so that will half that list, okay? In this particular case, it really doesn't make any difference, so we're going to skip it and move straight on into the synthetic division part. This is a degree 4 polynomial, so you will need to do synthetic division to find two different zeros to get you down to a quadratic that you can solve either by factoring or quadratic formula, or in some cases you may even get to use the square root property. Okay, so we'll start out our synthetic division here, and I'm going to start with a positive 1 just to see what happens. And I've got a 1, a negative 5, a 4, a 3, and a 9. We're not missing any terms, and it's in the right order, so I don't have to change anything. All right, so we drop the first term, multiply the 1 times the 1 and get 1, put it under this next one. Negative 5 plus 1 is negative 4, multiply, put it right here, combine we get 0, multiply is 0 again, combine is 3, and we multiply, and that's going to give me 3, which gives me 12, okay? So that one doesn't work. We're looking for a 0 right here instead of a 12. So we won't be using the 1, okay? Let's try 3. Positive 3. Same setup, 1, 5, 4, 3, and 9, because remember that one didn't work, so I don't start over with the quotient just yet, okay? Still got to find one that works first. Drop the 1, times 3 is 3, and that's negative 2, times 3 is negative 6, and that's negative 2, times 3 is negative 6, and that's going to give me negative 3. Negative 3 times 3 is negative 9, and that will give me 0. So I have found one, okay? Positive 3 will work. Now it is possible that positive 3 may work a second time, so you can try it again before moving on to the 9 or any of the negatives if you want to. So I'm going to go ahead and do that. It may not necessarily work, but we're going to try it and say, whoops, sorry. That won't work to tell me anything there. I need to start back over with the quotient, okay? Once you find one that works, you can then start to take the quotient apart to finish out your problem. So I've got 1, negative 2, and negative 3. Okay, we drop the 1 times 3 is 3. That's going to give me a 1 times 3 is 3. Another 1 times 3 is 3. And last, we get a 0 at the end. So it does turn out that 3 works twice. Okay, so we do have that repeated x there. Now, we can work on this quotient. That quotient is quadratic. X squared plus x plus 1. All the coefficients are 1 there, okay? And it's not going to factor. First, it kind of feels like it should, but two factors of positive 1 would either be two positive 1s, which would give you a positive 2x, or two negative 1s, which would give you a negative 2x. We don't have that, okay? So what we're going to have to use here is the quadratic formula. A, B, and C are all 1s. And so we're going to plug that into x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And you may run into one on the test that you're going to need to do this on, so you need to be sure you know how to do that quadratic formula. All right, so if we plug everything in, x is equal to negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1, so minus 4. We are going to get an imaginary number. And 2 times 1 on the bottom. Let me scoot that up a little bit more and we'll work on that. Inside, or underneath rather, the radical, we're going to get the square root of negative 3, which is an imaginary number. X is going to be equal to negative 1 plus or minus I on the square root of 3 over 2. Okay, since that's imaginary, we will need to write that as 2, whoops, clicked on the wrong thing, as two different zeros, okay, two different terms rather. So what we found from the synthetic division was we found that we have a 0 of 3. It has multiplicity 2, which means you can either write it twice here in the list or just put multiplicity 2 so that we can remember to get two factors in for that one. And then I've got the positive version of the one we found, negative 1/2 plus I on the square root of 3 over 2. And then the negative one, negative 1/2 minus I square root of 3 over 2. Okay, so that gives me 4 different zeros. 3 is there twice, 1, 2, and then I've got these two imaginaries, 3 and 4. Okay, so let's scoot up. That's my list of zeros. But we also want to write the polynomial as a list of factors, okay? And so now here is where you would normally put that leading coefficient. You would make it a constant multiple and you'd put it right here. Our coefficient is 1, so we don't need it, okay? We don't have to put it there. We can start with our factors. All right, I'm going to write my factor from the x is equal to 3. It is multiplicity 2, so that will be x minus 3 for the factor, and then there's 2 of them. So we put a square right there. And then my other 2 are going to be those longer, more complicated ones. X minus the negative 1/2 plus I square root 3 over 2. We'll work on that one in just a minute. And then if I've got enough space here, let me squish this over just a little bit so we've got room to write it. X minus negative 1/2 minus I square root of 3 over 2. Okay, if I clean those up a little bit, it'll be a little easier to write. P of x is equal to x minus 3 squared times x plus 1/2 minus I on the square root of 3 over 2, and x plus 1/2 plus I on the square root of 3 over 2. Okay, and that's our setup. Okay, that is the solution to this problem, because we are asked to write the polynomial in as the product of its linear factors.